Hello and welcome back to our channel. Today we'll be working on question 2 from the 2007 MAT. The MAT is the Maths and Computer Science entrance paper for Oxford, and it also applies for maths students at Warwick and Imperial. So let's get started. Question 2 for all applicants. Let fn of x equal 2 plus negative 2 to the n, all multiplied by x squared, plus n plus 3 of x plus n squared, where n is a positive integer and x is any real number. Part 1. Write down f3 of x. Find the maximum value of f3 of x. For what values of n does fn of x have a maximum value, as x varies? Part 2. Write down f1 of x. Calculate f1 f1 of x and f1 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 of x. Find an expression simplified as much as possible for this function, where f1 is applied k times. Part 3. Write down f2 of x. The function below, where f2 is applied k times, is a polynomial in x. What is the degree of this polynomial? Pause the video to have a think, and once you're ready, restart to see if you were correct. So, let's get started with part 1. Firstly, we'll write down f3 of x by replacing every single occurrence of n with 3. This simplifies down to negative 6x squared plus 6x plus 9. Now, we want to find the maximum point, so we need to have f3 primed of x, which is the derivative, which is negative 12x plus 6 equals 0. This can be solved to give x equals 1/2. Now, fn of x will have a maximum point if 2 plus negative 2 all to the n is less than 0. So n must be odd and greater than 1. And that's part 1 solved. Now, let's move on to part 2. f1 of x is quite simply found by substituting 1 in for every occurrence of n. We therefore have f1 of x equals 4x plus 1. We can now find f1 f1 of x by writing 4 of something plus 1 and substituting 4x plus 1 into something. This simplifies to give 16x plus 5, but I'll rewrite this as 16x plus 4 plus 1. You'll see the reason why later. We can then continue by writing f1 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 of x is 4 of something plus 1. This something, of course, is the result above, 16x plus 4 plus 1. Therefore, we can see that f1 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 of x is 64x plus 16 plus 4 plus 1. Now, we'll notice that this second half of the expression is a geometric progression, and therefore we can sum it to give our nth term. For f1 to the k of x, which is the notation for the above, then we have 4 to the k of x, which is evident, plus 1 multiplied by 4 to the k minus 1, all over 4 minus 1. This is equal to 4 to the k of x plus 4 to the k minus 1 all over 3. And that's the answer to part 2. Now, let's move on to part 3. We'll notice that f2 of x is 6x squared plus 5x plus 4, and has degree 2. Now, if we substitute in 6x squared plus 5x plus 4 back into f2 of x, then we'll get a function in degree 4. Now, you might be tempted to think that every iteration of applying f2 of x will simply increase the degree by 2. However, you'd be quite wrong there. If we take the second iteration of this function with degree 4 and plug it back in, we'll find that the term of degree 4 and the term here of degree 2 will give a term of degree 8. Therefore, following this pattern, we can deduce that applying the function k times would give a polynomial of degree 2 to the k. And that's the final answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.